So I would like to thank everybody connected and the people in the room for joining. Today we have Patrick Hochstenbach as a speaker. He also does his PhD at Ghent University. He has worked for libraries for 25 years and he wrote a very popular software which is used very much for finding full text documents. And he's now going to explain part of his research with reference to the rest of his projects. So Patrick, up to you.
Thank you. So I'm going to talk a bit today reporting about the current things we do and how we think about scholarly communication in academia. Let me first explain a bit what the real problem is. And this is the way how I explain it, how scholarly communication is working to my friends, because it's a very weird world. When you are working in academia, you get paid by all the citizens in your own land or in the whole Europe. The taxpayer pays all your income to make nice research, papers, and all these things you have to give for nothing to the publishers, and these publishers ask you to do for nothing all the review and all the things to make these publications better, and then the publishers will send these papers back to the libraries who need again money to buy the things you already produce for nothing. And this is a whole cycle that is how this publication world works, and it's quite weird. And that's why I needed to explain it to my friends. And this is a cartoon I made 10 years ago, but all the things are quite relevant these days. So this is my only slide about physics I will do today, because it seems in some way from all the configurations we could have how the scholarly publication is working, we seem to be stuck somewhere here in this world, in a scholarly publication world that needs very much energy, and the profits are quite high, and there's quite a large of a login. Because as a researcher, you can't just say, I will publish in any kind of publication. You know, you want to be in this high-ranking journals. And these profits are really quite high. So this is quite a recent graph here that shows here that the profit margin of Elsevier is about 35% there. So this is really amazing how much money you can make by just publishing free research. So if you compare it with other kinds of industries, it's quite amazing. This has a huge effect also on libraries, because libraries need to buy all these articles and these publications. And it's quite hard because, of course, you want to read what you have written, but you also want to read what all the other researchers have written. And many universities, also even the biggest universities on the whole world, can't have the money to buy all these publications. So there's a huge of universities that are just cancelling their subscriptions because it's too costly. Yes, of course, since 20 years we are working on open access to make it a change there, to make it easier for the whole world to get access to this research publications, and it is working. So you see here what the institute here does on open access publishing, and there's also many tools that came available to do this kind of publications. So you have here the in Vimeo system, but worldwide you have the ePrint and DSpace and ePress. It's all can be used to register your research in institutional repos. Also, at the other side, there is also software like Open Journal systems to create open access journal publications. There's also decentralized peer review systems where you can ask from this service here, please review my papers. And there's also many kinds of other kind of services around archiving. And how is this system working? Well, since the early 2000s, librarians made the OAI-PMH protocol, which makes a standard protocol to get data from this kind of systems to these kind of systems. And this is working well. So in the whole world, this is the way how you can, external service providers get access to articles in these systems or the metadata about these articles. But for all the other types of possible interlinking or exchanging of information, that there is not really one protocol. It's mostly done via HTTP, and it's quite an ad hoc way how these things can be interconnected. And we hope that we can make a better situation, that we can have an answer to get rid of this ad hoc and make a real protocol that all these systems can talk to each other. So there are two ingredients needed to make a new scholarly communication system. And this is what I'm going to present here, and what the current thinking is, how this can be done. First, we need the coupling of functions, and then we need to decentralize all these services. So what do I mean with decoupling? This is already quite well known. So this is an article by Roosendaal in 1997 that already said, well, you need actually four functions to do all of scholarly communication. First, you need to do some registration, so you can make as a researcher, you can say, I am the first one that had a new ID. Then you need to have some kind of a certification, so that you can have all kind of reviews and to check if these claims are really true or not. Then you need some kind of an awareness function, so that more researchers in your own environment or your groups learn that this research is available, and then you need also some kind of archiving to preserve your scholarly record for a long time. Well, each of these functions are currently being pushed into one aggregator, one publisher that does all these functions in one thing. But there's no law that says that this must be done by one service. So it can be done in many ways. It can be done on multiple servers, and this is what we mean with the decoupling of services. And this is quite important, because these services, if you can do them well, it defines a value of your scholarly artifacts, and the value is not in money, but in reputation. So if you have a preprint article and you publish this in the linguistic archive, you are already part of the physics community. You already have a way to say, I am the first person in the world that has this new idea. So there's some kind of registration. There are other people that are reading this and that say, well, this is good or not. It's some kind of certification there. Most of the physicists start every day by just reading what is new on the physics preprint archive. So there's some awareness and also archiving, and all these other kind of services that use this information in a new way. They get index in the search engines that can be overlaid journals that make new journals about this preprints, and it can also be indexed in the ANI databases, because if your article is part of the Web of Science, it has a higher value because it is a very prestigious article. So every step here makes your article more of an academic value. So if you want to make a new scholarly infrastructure, you need to answer these questions. If you have some paper here, you want to know, yeah, what is this paper here? What kind of value I can have from this thing? Is it part of a real website? Is it part of a good journal? Is it cited? Is it peer? Is there some peer review there? So if you can answer all these questions, you have more trust in the article you have just found. So let me talk a bit about the decentralization. So this slide you already saw yesterday, and I think in every thing about the decentralization, you see this slide here, how you are really locked in the many websites of the vendors. But also for scholarly, the communication is the same kind of thing. You just exchange Facebook by Elsevier and Google by Wiley, and you get the same kind of systems. It's very heavy centralized, and it's very hard to make a good innovation there. And if you're looking at the scholarly landscape, what the big publishers already are providing there for each stage in how articles get produced there, you can see all the publishers already have the complete control this how this can be made. So you are really locked in this kind of cycle. Also, if we are in the library world and the European world try to use open standards there, we are also making use of this very centralized way to work with data. So if you are an institute and you have on your institutional repo an open access article there, of course there is one layer there because you want to have it have a published version. So there's one copy there to publish a website of the metadata and the article. Then you need another kind of layers to do some identity or search engines or some kind of an indexing in Web of Science. All these things all these layers are used to build up the currently scholarly communication infrastructure. And if some institute here, say Institute 42 here in this list, want to know if someone citing my data or my paper here, you need all this thing in between here to answer this question. And our question is this the only way to do all this stuff? Wouldn't it be easier, let me skip this one, that one institute just sent a message to the other institute, hey, I cited your data set. Then you don't need all this infrastructure in the middle. And this is the kind of research we are doing now, is how we can send direct messages to all the institutes to make a decentralized network, to make all these functions of scholarly communication possible. And for this we are using a linked data because it's nice to link, because then your data doesn't have to leave your institute. But also we are using the solid way of working with data, because all the protocols we have until now are really read protocols. You use this protocols to index data, but there are not very good protocols to write data to nodes in the network. And the Solid protocol gives you this opportunity to read and write data, and update data and send notifications back and forth. So what can we do about this? There's really a road to decentralization, and it's not a binary thing that you say I will do total centralization or not. There's a whole range in between there. So the most central way we are thinking about is just publish your data on your own homepage. That's the homepage of the researcher. A bit less decentralized is just put your data in an institutional archive or in a community portal, or the most central way is just give it to Elsevier. And we are trying to find out what is the best way, how should it work in this case and this case and this case. We already know how it will work in the last case. So this is what our research project is about. It's the melon thing, where we imagine that every researcher in the world has their own pod environment, where they can store their scholarly artifacts, and we call it the researcher pod. And this is the pod where every researcher can read and write data. It's really their own space. And this pod is using the solid protocol to communicate with the rest of the world. So you have all the nice link data and read and write protocols to do interactions. And the most interesting protocol we use for our research is the notification protocol. And it needs some kind of an inbox. It's a kind of a mailbox, a mail kind of system between pods. It is like mail, but it's much more structured in data because it's using linked data as payloads. Because every researcher, or many researchers, will use these pods, and these pods are really standardized with the solid protocol. You can imagine there will be apps available, these scholarly apps, where every researcher can manage her own pod environment. And this scholarly dashboard is a kind of app to upload new articles to the pod environment, or new data, or to add metadata, or to communicate with the rest of the network. Then the nice part about we are using this solid protocol is that we can use, if you can make a scholarly dashboard for one pod, it can work for any pod in the whole world. So if you move to another institute, you can bring your own pod with you. You can use your scholarly dashboard, or you are not dependent on the pod anymore. Any scholarly environment or a community can make the most specialized and most nice websites or the pod dashboards for their own community. And it can work for every pod in the whole world. Well, if many researchers would have these own pods and own applications to work with this pod, then there can be some kind of communication there. You can researchers worldwide can read each other's articles, or even with the pod environment, you can say this article is still in a very early stage. I want to give only a few of these researchers access to this data. The pod can do this on a worldwide scale. So if here I have a researcher A and a researcher B, B can read this article and can send a notification back, like I like this article, or there was something wrong, and all can be done via the solid protocols, via a notification. And these notifications we are using to define how these network nodes are communicating. And we in the research we do, we specify how these notification messages should look like, so that it can be used on a worldwide scale. So these notifications can also be used to register data. Say you have your own pod and you want to register a new article in your own institutional repo. You can just send a message to this institutional repo if it also would have an inbox, and this institutional repo can import the metadata and link back to your article. So this is a way how institutional repos and also researcher pods can work to register data. This can also be used for all the other functions I mentioned in the start of my presentation. So here's in a way, a bit a complicated way, how you can make an overlay publication on many pods. So say you want to start a new publication and you want to get input from researchers worldwide. You can ask them, I would like to have your article and your article and your article in my new publication. Then a researcher can send via a notification an offer to this journal here from I would like to publish in your journal. And this journal can link them back to this publication. And there's a whole network of researchers that have also their pod environments where they can make reviews or, and to check if this article was okay or not. So it is using the same kind of notification protocol to do this, all this, what we normally do in centralized websites. The same kind of system you can do for all the kind of things. You can use it to make our awareness stuff. If you want to have a centralized database that wants to keep up to date with the most latest research, then it can just listen for all these notifications and say, well, please index my article in this database. So this is a bit how this messages look like. So we are using, on top of the existing solid protocol, we're adding a kind of a profile that says how these messages should look like. It's all based on JSON-LD activity streams messages. And here you see one of these messages where some researcher announces an article. So this is the article of Bob here, and it announces it to another researcher named Alice. So these are the messages that go back and forth between these systems. We need to be very precise here because all the messages that we send back and forth are started by humans. So all this values are created by humans. Humans start a review. Human starts to register something at a database. A human wants to do a citation there, and this protocol helps to have humans and machines talk to each other because all these values are human interactions. And this is a bit where we see our protocol on top of existing protocols, because there are many protocols that do machine-to-machine interactions, but we are really targeting what humans do and how they can express this in a more structured way. This looks a bit very technical, but of course then you have your scrolly dashboards that makes this one into a nice interface. If you want to learn more about the protocols we are making, here's the website that shows you the standards we are now creating. If you do this on a large scale, then you get a whole network of decentralized and decoupled services, where all the pods are here. These are this yellow things here, and the blue ones are the service providers that are still there, but they can use they can be used to add more values. And the whole protocol is about how all these networks can talk to each other. Well, why do we want to do these things here? What is another kind of use cases what we can tackle there? Say you're on the web here, and you find on your social network that some article says in the Large Hadron Collider they created a new black hole, and you want to say, well, is it in real stuff or not? You want to have you want to know, can they trust this article I found on the web? And again, you can use the results of this network to get more information about this article here, because you want to know, yes, oh yeah, it is really what is the case. Well, because all these network nodes were interacting with sending notifications back and forth, we are also making specifications how these notifications can also be logs. You can have each node can have an event log about the notifications that were sent back and forth that add value to all these articles. So based on these event logs, a researcher can use their an app environment to find out first what this article is, then go to this article and read the log. And the log says, well, there was, because of this article was sent a review by this researcher here. This log also says, well, my article was registered in my university institutional archive. It is real part of an institutional publication. Well, this browser can get here and read also there the log. What happened to this article when it was registered here? Well, it got published in a web journal, and then you can go to this log here. What happened to this article when it was published? Well, it was reviewed by all these people. And this way you get a value chain that gives you more trust what you need to do with this article you just found on the web. And this is what we want, and certainly if we want to make the results of science more accessible for the rest of the world, you need these tools for the public at large, because not everyone is the real specialist and can do all these steps by hand. So this was the research what we are doing. We are also doing these things for real. So this is not only a research project we do in Ghent. There's also worldwide. We are implementing these techniques in real networks. But therefore we need to take a step back in the decentralization, because we don't say, well, the whole world needs to have all a solar pod environment. All these protocols can also work on a much higher level. And we don't say get rid of all the institutional repos. No, they have a very good role in our network. And these protocols, the notification protocol, can be introduced also in this kind of networks. And this is what we do in the core notify. Core notify is a configuration of open access repos. It is a worldwide confederation that gives advice to institutional repos worldwide what to do and what are the next steps to make research more open and open access. And they are primarily focused on how to make overlay journals and peer review services possible with decentralized protocols. Here are some of the people involved. So there are people from very different institutes. Yes, Herbert and I are the technical advisors. And last year they got a huge funding from the Arcadia to start this project for real. And here on the right-hand side, you see all the partners we currently have to implement these protocols. Maybe you don't know most of the names, but there are many repos there. So Hull is the big repo in France. We have overlay journals. We have peer review services. We have indexing. We have preprint services, and we have a whole mix of different institutes that want to work with this, and they are implementing the protocols I just showed in my presentation. Not only they do this for their own institutional services, they are also talking to the vendors and creators of institutional repos like DSpace, Dataverse, Invenio, and some Vera to also implement these protocols in these kind of services, because you don't need to look at the Solid as a very big chunk that you all need to implement. You can take chunks out of it and start implementing it. What we are doing in Ghent, we are doing it the very an easy way, because we already have a very good working and solid application. So we can just implement it on our pod, and then we can immediately doing the integration with this kind of services. So the technologies we are using is linked data notifications. This is the base protocol that we take out of the Solid stack, and we implement this using activity streams. That is in kind of a structured way to say what kind of payloads you are sending in this linked data notifications, and this is very much related to projects that are not only used in our scholarly world, but also in other kinds of environments. So Servant-made is locally, that can be used as a very personal way to make a very personal decentralized network between researchers. We are doing it in the Mellon around scholarly communication, but we also very closely are working together with people from DANS that are using the same protocols for memory institutions in the Netherlands. So you have there museums and archives that want to make a decentralized network. Also, DANS is working on the same protocols to do this for research data. And we are currently looking at how we can connect these protocols with the things that are happening in Activity Web. And there was yesterday a question here, what is the relation between services like Mastodon and Solid? Well, we are looking into this because you see currently in Germany and the Netherlands, huge wave of institutes that are starting to implement Mastodon in their institutes. So in the Netherlands, you have a nationwide research network that says we are we are doing an installation of Mastodon for every institution in the whole Netherlands. Well, Mastodon is using protocols that look very much like what we do. So if we can ride this wave and use this kind of popularity of new kind of decentralized services, then we can make a change there happen. So what we are very interested in is how we can make Mastodon and Solid how they can talk to each other, and how we can make use of these kind of things. So that is in the big line of what we are trying to do. There are many technical details I didn't talk about here, but you can read it about in this website. So I already mentioned our event notification spec that is now used by all these things that I mentioned in the last things. What you also need is some kind of an automation and orchestration there, because there are many steps needed to do an scholarly publication in the right way. So what we are currently doing is creating what we call orchestrators. An orchestrator is kind of a robot that helps all these networks to do this, the whole communication and message exchange in a right way. So here we have also made a kind of specification, and this is also used by the archive world and the scholarly communication world. And we made one implementation of this. Is also an open implementation where we can give a robot access to this whole network. To make this robot work, we need a way to specify a kind of rules that institutes can say what should happen, or what they like that should work in this kind of networks. And for this kind of business rules, we are using we are investigating now how decentralized networks can define rules for this kind of networks. And for this, we started the W3C community group. It's called RDF Services that define this kind of rules. Also, we are working on this artifact life cycle event log. That is the log you need. That all these bots can say, well, these are the notifications that were being sent in the network, and this is the log you need to make this trust happen on the network. And if you want to learn more, then we have also a website, the NOS website, that shows you all the publications and the presentations we are doing, and the current research we do. And I think this is the end of my presentation. Thank you.
So thank you, Patrick. It would be nice today if you all agree that we take first questions from the people remotely connected, and then from the room, if any. And also, we said yesterday that in Restaurant 2, which is next to IT Amphitheatre, we will go all together to have an informal lunch and continue the discussion for any subject related to solid or publication paths or notifications and other software related to this. So you are all welcome, those remotely connected, if you are willing to walk to Restaurant 2. So let me just check what is going on Zoom. Sorry. Sorry. I don't have anything right now. So let me just ask the one question I have in case people later on have something to comment or ask. If every researcher keeps their publication first, in the first place on their personal pod, who guarantees the scientific value of that paper?
Yeah, for this reason.
It was towards slide number 18 that you started mentioning this, if I remember correctly, and I was impressed.
No.
No, sorry.
It was this kind of an system here. So the scientific value is working the same way as it is working now. So how is the value of the scientific value of a research paper now? Yeah, is well in the how we do it now is that every researcher does reviews of each other's papers there. So it's not the journal that says, well, you have a value or not. No, it is because you have two reviewers or three reviewers that say, well, your paper is good. Well, in this kind of networks here, you have this peer review services. Let's sit here. That give you peer review services on top of the publications that are in your own pod. And then you not have only a network of two reviewers or three reviewers. You have a potential network of hundreds of reviewers. So this is also a way to reconsider how review should be made. You can ask there, is it the best way how we currently do a review, that you only can publish in a journal if you have three reviews? Would it be easier if you just publish it on your homepage and get hundreds of reviews there? Is there a case there to make a post-publication review a possibility? And that is a whole argument you can make for this. I didn't provide the link here, but there is also research on this one. So I think this will strengthen more what we can call the scientific value of these articles.
Okay. It's a fair point. And you mean that the big article that you had on the slide that University of California couldn't reach an agreement with Elsevier because the money was so high that the university could not afford it,
yes,
will go away, this problem, because the university will not anymore feel that the publishing with Elsevier is a sine qua non condition for having the papers worth citing or trusting.
Well, it is this happening in institutions worldwide. So they can't cope with every year it's about 20% price increases of all the publications. And even if you have a big university like the University of here, they can't pay all these things, and they in some way you need to break this system. And the big universities are now promoting to do this open access publications, but then you also need a kind of a system to make it easier to do all this open access way of publication. And what we have are these protocols that are more than 20 years old. So we say, yeah, of course, we need to go all into open access propagation, but we need some kind of new protocols that help all these things that are happening now. So there are now hundreds of institutional repos worldwide. There are engines that index all this data. There are also services like that gives this open peer review. So there's open journal and systems there, but all they are using is this ad hoc network protocols. And we say, well, let's make it into a standard way so that it can even go faster and have a more structured way to exchange all this data and make this value change possible.
Thank you. And we have a very much related question here from Alexander, who is very much doing research on notifications relevant to yours. And he asks, what would be the motivation for the reviewers to review papers? Would it work in a way where if someone wants to get a review, they would have to commit to provide reviews? In that case, how would this start? Or is there some other idea?
Yeah, I need to remind. A few weeks, I read a huge paper on this. Explains there why it wouldn't be a burden for the researcher, because researchers also review papers because they want to keep up with the current research that is happening. So they do it anyway, but now you get even a more controlled way how these reviews can happen. So I don't think that when journals stop you sending mails, please review these papers here, that's suddenly all the researchers in the world say, okay, my job is over, I won't do any reviews. So I think that it is part of the process of you being a researcher, but maybe I can better give you the link to the publication that talks about all these reasons why.
Okay, give it to me. I shall put it on the Indico event together with the slides separately. Okay, Alexander is happy. He thanks.
Thank you.
If we don't have anything else here now, we can keep the plan to go gradually to restaurant 2 before the crowds assemble and have lunch with anybody else who wanted to join, as we agreed yesterday, and continue the discussion there. Yeah. The technical discussions that can be done around salad and stuff. Good. So thanks again.
Thank you.